No, but I think in general, it's about like, so when we're talking HPC for AI, then if you're a company, like a commercial organization, you're going to use what's best serving your purposes, right? And most SMEs, for example, come from a cloud native environment. And that's not necessarily because cloud is the only option. It's just that cloud is it's there. It's kind of in your face. That's where you get started. And there's also a lot of services, like it's built for uptime, it's built for scalability, etc., and really low latency and automation. And that's really good if you want to get something on the market. But if you have to do a lot of computations, etc., and use a lot of GPU power for compute and for training, then cloud becomes really, really expensive. So for those use cases, it might actually be more economically beneficial as well to use HPC as a complement to cloud. People don't really know about that. So what we have been discussing a lot and what I have been focusing on as well is to kind of let SMEs know that this is an opportunity. The EU is really investing in enabling private sector companies to use these resources because they see it as important strategically to also build competence within this area. So sort of how do we communicate to SMEs? Like how do we reach them? How do we get them to understand that, this is like, there's millions and millions of euros worth of resources and compute and support and services available for free. Like literally, it costs nothing.
Waiting for anyone to just
waiting
grab.
to be grabbed.
Yes.
I mean, I think,
it sounds too good to be true, but it's not.
Does, yeah. So you were speaking about the AI factories, and we'd love to hear more about, what that actually is in EU. But to come back to what you said and what the main problem really is, because I guess we have the very famous cloud providers today, and that they have amazing services, and they have an awesome tech stack, and they have great, supporting system, and it's very easy to get started there. But the problem, I guess, then, as you said, is that if you have some kind of bigger project you want to run, it becomes really expensive. And then we potentially in Europe are lagging behind because we don't let some companies at least make use of data and AI to the extent that some other companies can. Is that basically what EU is seeing as a problem and they want to fix with this kind of AI factory?
I would say so, yeah.
Yeah.
But go ahead.
Yeah.
Yeah, no, I think that's a really important point, right? Because again, you see sort of everything is coming from, like, all of the cloud providers more or less are based in the US. Like NVIDIA is based in the US. Yes, we have AMD in the Netherlands, and that's really important. But I think it's also like on the hardware side, it's an analogy that NVIDIA is like the cloud providers, really, really good at building an ecosystem around the hardware that makes it really easy for anyone to just come and use. It's kind of plug and play.
And hard to leave NVIDIA as well.
Exactly. Yes. And it's kind of the same because when we speak to the PDC people at KDH, so Parallel Data Center, to clarify, the guys who work with Dardal, the supercomputer there, they kind of have a preference for AMD in terms of the hardware specifically, but they work directly on the hardware. So they don't actually need the ecosystem around. So based on what I read from them is that the AMD hardware might actually, in some cases, be better than the NVIDIA GPUs, but the ecosystem around it makes the NVIDIA GPUs so much more accessible. And then you're locked in. And it's the same with cloud, right? Because you start out and you get like an AWS instance, for example, and then you have like a lot of plugin services and then you have a lot of libraries that you can use, etc. So it's so easy. But then like the hidden scalability of the cost, right? It's going to increase massively when you start using more and more compute. But of course, at some point, it might be.
But we don't, have the misconception that cloud or HPC is for everything. I mean, it's a research and development environment. It's for big computation. It will never replace cloud completely. And the current access to EuroHPC right now is for explicitly research and development projects. So it's not for deployment. It's not for everyday operations.
You couldn't deploy a ChatGPT clone on HPC.
I guess we'll come back to the AI factories, but one of the points there is that they are supposed to be more general environments, providing access to these frameworks, which currently might exist in the cloud and not in HPC, And it explicitly says actually in the call that it's supposed to be an environment where you can train, you can validate, you can test and deploy models for research.
Could we just summarize the context? What is the AI factory? What is happening now in time? So just to frame, you must put the wrapper on what. So
we brought this up because it's sort of on our mind right now. We've been talking a lot about it. So the call just opened last week. I mean, it's been a long time coming. There was the decision by the European Commission in January to boost AI, and then there was a concept paper published in the summer. And now finally, EuroHPC opened the call. Everyone is free to apply. The first deadline is in November. And so there's a mobilization happening right now in Sweden. Hopefully we will apply and hopefully we'll get funding to establish this.
That's interested in that. What should they search for, Google for? Is it for AI factory?
I think that should lead you to the right place, or combined with EuroHPC perhaps.
I think it's a super interesting topic. The theme for the podcast of tonight is a bit more into the infrastructure, to the high performance computing. And I think it's so interesting given the news in the last couple of months where we see, especially the big tech giants, investing insane amounts of money. Just saw, Elon Musk and XAI releasing the new Colossus data center, 100,000 H100 GPUs. And basically bringing down the power grid, of a state in the US because they put so insanely big data centers in production. And when they actually train the new Grok 2.0 there, they actually they have ramifications to the power grid and the stability of the grid for the rest of the whole state.
I remember reading something that they didn't actually have enough energy to power all of them. Just a third of the entire Colossus machine could be powered with the existing energy available in the state.
Yeah, so in this sort of context, it's going to be very interesting today to talk about high performance computing and how that is dealt with in Europe and how we can, as normal people, as normal companies, maybe tap into this.
And I think then the need for things like EuroHPC and AI factories becomes even more clear, because it is to an extent that I don't think people understand. You need to put it into very understandable words, like it affects the whole power grid of a state to understand the size of the current investments in compute infrastructure. Anyway, it's super interesting topics, and I'd love to just welcome you here, Ingrid of Sandeberg. Is that correct?
Yes.
And Kjartan, Thor, Wikfeldt?
Well, to be precise, Kjartan, but I use Thor in Sweden,
Awesome. It's going to be a super interesting topic. And let us just do a quick round of introductions first. So Ingrid, how would you describe yourself? Who is Ingrid?
Oh, wow. Who am I? I'm an independent consultant. Let's start at that. That's my occupation. But I think I am an independent consultant because I'm very curious and I love to work with different things. And recently I've been working a lot with AI, both as an independent consultant, as a management consultant, as sort of operational in AI startups, and also as an investor. So I'm coming more from the general AI ecosystem rather than the HPC ecosystem specifically. And I've been working with Thor for a few months now.
Yeah, since May. I think,
since May.
And you have your own consultancy company?
Yeah, I have my own consultancy company. I'm also chairing Stockholm AI, which is...
And done that for a number of years now, right?
I've done that for a number of years. And for clarification, it's not AI Sweden.
No.
And Stockholm AI is a non-profit community. So everyone engaged with Stockholm AI are doing that on a volunteer basis. So I don't work for Stockholm AI, but I'm chairing the board since a few years,
And also do some angel investments, you said.
Yeah, so I've only done one, but in cybersecurity, it's an area that I've been very interested in for a long time. This company certified as sort of a more traditional cybersecurity, but I think that when you talk about security in a cyber setting, it's becoming increasingly related to AI as well, because it's more and more about intelligence and influence operations and political influence, etc. And I mean, we saw already in the 2016 US election how I think Russian bot farms was rumored to have reached, 1 million plus Facebook accounts. And I think as more and more information on internet is also AI generated, it becomes quite interesting when all of these big new foundational models are trained on the entire internet, and there's a sort of an inverse relationship between, I would say, quality and quantity of information. But generally, if you thought a lot about your content and you put it online, then it might be of better quality than if you're a troll farm who have, 100 accounts and per person or per troll, and then just pushing the same thing.
All empowered by AI now, which tenfold their productivity, so to speak.
Yeah, and I mean, it was announced, that was it today or a few days ago, that YouTube will have this like Gen AI video plugin starting next year, and I'm like, yeah, that's going to be great. Even more
garbage in, garbage out.
Yeah, noise.
Yeah, interesting times for sure. Thor, how would you like to describe yourself?
Well, I have a background in HPC. Most recently, I am leading this project called ENCCS. I can talk more about that later, what we do and so on. Yes. It's the National Competence Center in High Performance Computing. I work at RISE since 2 years back. Actually, the project is older than that, but the project belonged to Uppsala University before that. And before ENCCS, I worked at PDC at KTH in Stockholm, the supercomputing center. I was there for 5 years, and before that I was doing academic research.
What was your main field of academic research?
I was in physics, chemical physics. I used HPC systems as a user, as a PhD student, and then postdoc and researcher. So that was a key tool in my toolbox. I was fascinated by this middle way to do science. I mean, there's the traditional approach to science is theory and experiment. But then since decades back, you can actually do computer simulation. And I thought that was so cool, combining theory and it's sort of like an experiment, but on the in silico on the computer. Exactly. And visualizing molecules, atoms, electrons.
I'd love to go into a discussion with you about AlphaFold, and they have what was the new one that simulates proteins as well? AlphaProton or something?
I actually didn't see that news story. No, AlphaFold is fascinating, and it's not my background. I mean, it's more in the biomolecular domain. But as far as I understand, it's a game changer.
Yeah. But that's not the topic of today, right, Henrik?
No. So we're going to talk about HPC and specifically how we do it in Europe, and specifically how we do it in some in the projects that you are working on.
Yeah, should we start with the ENCCS? And if you were to just give a short background to what it is, how did it get started, and what people can make use of.
Okay, so I mean, we are the EuroHPC National Competence Center in Sweden. So I need to tell you what EuroHPC is maybe before it makes sense to tell you what we do. I mean, EuroHPC, it's one of the European Joint Undertakings. Gemensamt företag, it's like a funding agency. It's a common effort by European countries to, in this case, fund usage and work and research in high performance computing. And the JU, EuroHPC JU, was formed in 2018, and the goal was already to rapidly expand the supercomputing infrastructure in Europe to actually start competing. I mean, in decades and decades before, 2018, Europe was never even close to the top 10 in the world. There's a list of biggest supercomputers in the world, published twice per year. Europe was never there, but they've managed. So today we have 3 supercomputers in Europe on the top 10 in the world. The biggest one actually being in Finland. Yeah. But it's not enough just to build out the infrastructure. I mean, you need skills, you need awareness creation, you need training, you need consultancy. And that's why the EuroCC project, so Competence Center, was established. Pretty big project with 33 countries involved. And we are currently 32 national competence centers in Europe. We collaborate tightly.
And what is a competence center?
Yeah, so I mean, we employ HPC experts. We have various backgrounds, but a shared passion for and interest in HPC. So what is a competence center? I guess there are multiple. There are other JUs actually. There are other joint undertakings. There will be a CHIPS JU with CHIPS competence centers to focus on the development of computer chips in Europe. But we are focusing on the HPC part. So we are a group of HPC knowledgeable people who reach out with support and help and awareness about the opportunities that exist today and also future opportunities like, we spoke about the AI factory.
So how does it work? Is it more like a consultancy that people in this center can actually go and work directly into some project for people that wants to or that's interested in it? Or?
Yeah, so there's room for proof of concept projects. We can work on proof of concept projects with SMEs and startups, which involves a little bit more in-depth consultancy and help and support, touching the code, looking into the code that is being used, scaling it, making it run on GPUs or whatever it takes. That's an important part. But much of our work is also somewhat more lightweight. I mean, it's helping to get access to EuroHPC systems, writing the proposals, all that paperwork. It's not rocket science, but it's not trivial either.
It's not. I hope you make it easier than traditional kind of EU applications.
Yeah, I mean, these are free resources, so you need to jump through hoops. I mean, it's simply not allowed to just open it up without any effort. There needs to be some competition to be able to hand out these free resources, right? But we help with that, and we can help to get started. We can talk to a client, talk to a company, hear what they are doing, tell them what we can help with, and we can sort of together mutually arrive at a conclusion whether it's worth it to go for HPC, and if so, we can help you get started. That's typically
so that's a EuroCC, and it's connected to EuroHPC. But then you had the ENCCS. It's a lot of abbreviations here. But so what's the ENCCS?
So it's an acronym for EuroCC National Competence Center in Sweden. Yes. We've actually been thinking about relabeling it to EuroHPC just to put the HPC in there somewhere. Otherwise, what is the competence all about? Anyway, so ENCCS, I mean, there is also an NCC in Finland, Norway, Iceland, Spain, Greece, North Macedonia, and so on, all over Europe. And we are this network of national competence centers that work together very tightly. I mean, we do events together, we share knowledge between each other. But in short,
if someone in Sweden right now needs access to more advanced compute infrastructure, they should reach out to you or to someone or to Ingrid or someone in ENCCS, and they can help them get access to more compute.
Yes, I mean, we are the gateway. We're a one-stop shop, a single point of entry into the world of HPC. If you need more compute, if you're limited in what you currently have access to on-prem or cloud, is it too expensive? Is it too difficult? We can take the conversation with you and evaluate your project. Is it good for HPC and help you get the access and get started?
So if I would put a theme on this podcast today, I would say, and please correct me or improve on it, we are talking about on how normal companies, smaller, medium, even in focus, can act and do in order to get access to hardcore, really high performance computing. And if you with effort, you can have it for free.
Yeah. So
then we need to learn a lot about what this whole thing, this is maybe a world so not so many knows about.
In a way, this is democratization of compute power, right? So I mean, this is specific. Our action, our project is specifically targeting SMEs and startups, because a big company can hire their own people recruit their own experts, build a team that just manages a big on-prem cluster, and they buy the cluster and they are happy. And there are multiple Swedish large companies that do this today, which you probably know. Yeah. And but this is simply not possible for an SME or a startup in particular.
And perhaps it's necessary for people that's not familiar with the term HPC. Can you just elaborate a bit more? What is the difference between like general HPC and AI compute or data compute infrastructure?
So HPC and AI, I mean, it's sort of like different beasts. HPC is a tool. It's a computational backend that you can do stuff with. You can do AI on HPC. You can do AI on cloud. I mean, the acronym is high performance computing. And this is a very old discipline going back, 50 years. or even more.
Computer.
Oh yeah, so Cray 1, Cray 2.
Is Slurm and these kind of tools still used?
Oh, absolutely.
Really?
Yeah. Well, there's always the talk of modernizing HPC as well. So, I mean, we might see evolution. Slurm is great. It's open source, fantastic tool for many purposes, but
Okay. Yeah.
I mean, for at least the traditional use cases of
Yeah. Sure.
But I mean, there are different needs.
Yes.
I mean, the people we talk with too, often they're completely fine with Slurm. Other times it's like, why cannot not programmatically access the cluster?
Okay, cool. Okay, so, but HPC in general, it can be used for much more than training AI models. It can be done to do simulation similar to what you did in the past, I guess, for more chemical kind of simulation or biological, or if someone wants to build a circuit board and needs to simulate the potential design of, you know this better than me, but I guess there are so many other applications than just training AI models on this, right?
Yeah, I mean, AI is the new kid on the block. Really.
But if we talk about, just to paint a picture here, we have one of the top 10 supercomputers in Europe now. One in Finland, Lumi. What is Lumi? What is it? Is it a GPU based? What is it?
A lot of GPUs.
A lot of GPUs, right?
It's a lot of GPUs. Yeah. Well, Lumi is an AMD machine. It has AMD GPUs, AMD CPUs. There are other supercomputers in Europe that have NVIDIA cards instead, H100, A100. But what is it? I mean, it's okay. So I think you have to have a different mental model of what an HPC system is, a supercomputer. They're sort of synonym words.
Exactly the same.
No, it depends on whom you talk to and what your background is. I mean, some people understand supercomputing to mean like the high end of HPC, like really running on the whole machine, massive scale simulations. While HPC is maybe just having access to the best inline GPU card, which enables you to do high performance stuff. I mean, it's much faster than running on your laptop. But in other aspects, talking about supercomputing can also be easier to relate to somehow than HPC. It's an acronym, high performance computing. Sounds very computer sciencey somehow. Mm-hmm. So I would be interested in hearing what you think about the difference between the two.
I mean, like, as a layman, I mean, like to some degree, I get the annotation. Is that for supercomputer or HPC, or the Cray computer, or like that whole architecture? Mm. And then now we have a very much a GPU-based architecture, which is essentially then the parallel computing, to do more mathematics, and of course, very suitable then for AI. So for me, then the sort of the modern discussion of HPC, for me, it's I guess GPU based at quite large scale. A lot of GPUs at the same that is sort of connected, so you can use them.
Okay, so I didn't quite finish the mental model I wanted to convey here, which is that a supercomputer is a bunch of nodes, compute nodes, which each acts as a computer with its own memory and own CPUs and GPUs. But of course, it's a very, very beefy computer. I mean, often you have 4 A100 cards on each of the supercomputing HPC nodes. Mm. And then you might have 128 CPU cores and lots of memory. I mean, 256 gig or a terabyte or something. And of course, and the key thing is that the nodes are interconnected. So it's perfectly fine to get access to a supercomputer, an HPC system, and run on one node. But the true power, the thing that makes it into a Formula One car in the world of computing, is that all of the nodes are interconnected. You can parallelize over all the nodes. So it runs lightningly fast.
Yeah, and typically now used to connect it to AI and generative AI and large language models, is that when you want to train one of those models before you put it in production, we are talking about computing hours or computing days of sometimes the whole computer. Or
days, months.
Months, yeah.
Yeah, but that's still is GPU hours you're talking about. So if you have a lot of GPUs and you can run them in parallel, it's going to be few man hours. So for example, we had a conference 2 weeks ago, where we were looking at some SME use cases, and there was this company, Supersight in Finland, who'd be working on Lumi to train a model. And he was like, so what would take me 15 days to train on my kind of powerful MacBook Pro takes me 2 to 3 hours on Lumi.
Yeah.
And then I want to try 10 different models. But I can do that in parallel on Lumi. So instead of spending 150 days, sort of chronologically, I would rather just spend 2-3 hours because I use the entire sort of the entire supercomputer infrastructure. So you compress the timeline a lot. But then, like Thor said, it works a little bit differently. It's not a production environment. So you have to schedule jobs a little bit differently. It's not going to have the same uptime, etc. But even if you have way worse uptime, 2 to 3 hours is a lot less than 150 days.
Yeah, but maybe to use the LLM example is a way to bridge to people who doesn't come from this world. So when you're developing the new model and then you train it for days or months, and then when you're done with the training and all that, then you sort of lock it and then you take it home, and then this is the product that you're now servicing in GPT 4.0.
Yeah.
So the difference is between all the hours of compute to train the model, the LLM, and then to bring it home and then productize it. So I think for many companies, if you understand what we're doing here with machine learning, is the difference between the training time and then to put things in production at home. So then you can have your one setup, how you actually use it with your customers in the end. But here, to compress the job of training the model, the underlying model, that's what this is all about.
And I think it's interesting to get back to the training versus inference time at some point, because even if you have something trained here, you will need to put it to production some days, and then you can potentially need even more compute. But I'll add that to the list, and let's get back to
but was that my layman's example, like to understand when we want to use a supercomputer in LLM terms?
And if you're adding something to the list, note down compute continuum as well.
Compute continuum. Okay, I'm getting
That's
very
a good one.
Yeah. Let's see.
No,
thinking Star Trek when you're saying that. Okay.
It's a cliffhanger. But I think going back to most machine learning models are trained they're first trained on data, and then they're validated, and then they're tested, and then they're put into production. And when they're put into production, that's where the customer meets it, right? But if the training and the validating and the testing is sort of not supercomputer intensive, you can have it sort of in a production environment. You can have it in the cloud, and then you can just deploy models quite frequently. But if each training is quite big, then you have a lot of lag between when you start training the model and when you sort of deploy it. And then if you put that in a supercomputer context instead, and you compress from 150 days to 2 to 3 hours, that's a very extreme example. I think it sounds very extreme. Then, you can deploy models much quicker, and you don't have to spend it because each hour is cheaper on these machines. And also, they're actually free, but even if you were to pay for them, because you can also pay for hours as well.
I think, great example. And I think it would be fun to just go through some example project, perhaps something you have seen recently being done. But before that, I'd just like to close the topic when we spoke about, HPC versus AI. And you also spoke about the biggest HPC clusters in Europe now, and we have 3 of the top 10 in Europe, which is amazing, and very glad to hear that we are starting to catch up, even though we are a long way to go. But we mentioned Lumi, and I guess that's the top one in Europe, correct?
Currently, there is an even much bigger one under construction right now.
Ooh. Can you share more about? Name the top 3 or something. Which one would you name that exists today to start with?
Currently biggest in the world
in Europe. In
Europe is Lumi, and followed by Leonardo. So the Lumi came in on the list, ranked number 3 in the world when it was built. I don't know 2 years ago. Now it's fallen to place 5, which is very expected because other extremely large supercomputers are being built. And what happened actually in the meantime was that the first exascale supercomputer was built in the US. So they broke the exascale barrier first.
An exascale is basically exapetaflop or
exaflop, indeed, yeah. So 10 up to the power of, is it 18? Yeah.
It's a lot of flops.
It's insane. Yes. And flops is like floating point operations per second. But the bigger one, which is being built, it's in Germany at the Jülich Supercomputing Center, and it will be called Jupiter. Not Jupiter with a Y, but with an I, like the planet. Yeah. And so that will be Europe's first exascale system, a huge success for Europe. I mean...
Do you know when it will be launched?
Next year, if I am not forgetting something. I think next year.
But it's it's HPC project as well. So
it's funded by the EuroHPC,
yes.
But like all the other EuroHPC systems, it's co-funded. But I mean, it's there's the EuroHPC funding and then national co-funding.
Mm. And then we have some Swedish ones as well. If you were to mention, we spoke about KTH and PDC and their kind of data center. And what else do we have in Sweden?
I mean, Sweden has a pretty strong history in HPC.
Yes.
I mean, there are two very old, in a way, supercomputing centers, HPC centers in Sweden. It's the PDC center at KTH in Stockholm, and it's NSC, National Supercomputing Center in Linköping. And there's been sort of a friendly competition between the two, and they've sort of taken turns. Well, they have varied over time, perhaps, depending on people involved. But they've taken turns to host the biggest flagship supercomputer in Sweden. Currently, the biggest system is at PDC, the Dardel supercomputer. It's a mini Lumi, exactly the same architecture as Lumi, except, smaller. And But there have been other HPC centers in Sweden as well. There were 6 before. Now the goal is to centralize a bit more in coming years.
And then we have some more AI specialized one, like Berzelius.
Yeah, some of the HPC centers in Sweden have some side thing. So PDC has been working with Scania, for example, hosting their hardware to some extent, while Linköping has collaborated with, so that National Supercomputing Center in Linköping has collaborated with SMHI. SMHI have been doing their weather forecasting calculations there, and most recently built the Berzelius AI supercomputer in Linköping.
And that's also being done, funded by Wallenberg.
Yeah,
right?
Yeah.
But you mentioned something, some new project as well. Is that something you can speak more about?
Are you referring to the upcoming Swedish EuroHPC system?
Yes.
Yeah, so that's super exciting. What is it now? 2 years ago, Linköping University, as the hosting entity of the National Academic Infrastructure for Supercomputing in Sweden, the HPC, organization in Sweden. They're hosting it, and they were tasked. They were given the mandate to apply to one of the open hosting calls for a EuroHPC machine. And there was a strong team of people writing the proposal, and they sent it, and it was evaluated extremely highly, and it was granted. And so the work is currently ongoing to procure a so-called mid-range EuroHPC system. Mm-hmm. So it's not going to be Jupiter, it's not going to be exascale, it's not going to be Lumi either, but it's going to be pretty good. So it's going to be bigger than the traditional so-called petascale HPC systems. It's going to be on the order of 40, perhaps, petaflops. Mm.
Is it going to be more like a Berzelius AI-based or more HPC general kind of cluster, you think?
The exact specs are yet to be revealed, but it's going to be a general purpose HPC machine. It's not geared specifically towards AI, but AI is still an important use case, so there will be GPUs. Exactly what flavor of GPUs will be seen.
Does it have a name yet?
So it's called Arrhenius.
Arrhenius, yes.
So that's a...
And what was the story here with the name?
Yeah, it's a good anecdote because Berzelius is there. Berzelius is an AI supercomputer. And if I tell you Arrhenius, if you're a chemist or a physicist, you think of Svante Arrhenius, who received a Nobel Prize, I believe, and he was living active in the 1800s. Could he have received the Nobel Prize? He was born.
I think he did.
Yeah, it must have. Anyway, so it's not named after him. It's named after Carl Axel Arrhenius, who lived 100 years before Svante and worked with Berzelius. So we'll have Arrhenius and Berzelius side by side.
So they were co-workers in the past, and now they'll be co-workers
reincarnated in the form of a supercomputer today.
Cool.
Great. And Ingrid, perhaps you started to work with Thor now for some months ago, right? Can you just elaborate a bit more? How did that get started and what you're working with?
So they're sort of building out the business development part of ENCCS, so I'm supporting with that. And with business development, it's basically marketing these resources and helping SMEs on the one hand understand what's there, but also helping EuroHPC programs to understand what are the needs of SMEs. So, for example, why are they using clouds, or what's required? Like, what are the pros and cons for cloud, and in what type of use cases for an SME would HPC add more value?
And for people that's perhaps not familiar with the history, and please correct me if I have the wrong history here, but traditionally it's been kind of hard to get clients, right, to HPC clusters, and or companies are perhaps not as interested as they should be potentially.
It's not on their radar, right?
Yeah.
What do you think, Ingrid?
Well, I mean, when you contacted me about this was the first time I heard about HPC. Yeah. So I think it's just like it's not on the radar, like you said. It's not something you think about. You think about training models or like using compute. You think about cloud.
Yeah.
Because I think it is, like you mentioned, it's traditionally a lot more of a scientific environment. It's not as close to the product. And when you're a startup, normally, or not normally, but oftentimes, you want to have something very close to the market, very close to the sort of production environment. And normally it's just when you reach a certain scale of computational requirements where it actually makes sense to put it in a different environment. Right. And train the models in a completely different environment before you deploy them. So it is only, and now, I mean, we're seeing more and more data and we're training larger and larger models. So for more and more SMEs, it might actually make sense. Mm-hmm. But it's easy, like we discussed before, it's easy when you start out in a cloud environment, you're sort of hacking together, you're getting some POCs, and then you find different things you might need more compute for, but you're already in a cloud environment and you're not really aware that there's something else as well.
So it's a threshold there for companies to get started with it.
Yeah. Is this where we go back to the compute continuum thing?
Oh.
Well, no, maybe we can postpone it a little bit. We could postpone it a little bit.
Yeah, but there is a threshold, right? Because if you, I mean, because it is a different environment.
Yes.
So if you start out in a cloud, maybe you build your MVP, you get your first customers, you train a little bit, you realize you can train a little bit more, you scale, you raise some money, you get some revenues, you want to train a little bit more. And then sort of, because cloud is built for scalability, right? So you scale a little bit more, you pay a little bit more all the time. Mm. At some point, you know, it's going to be, the cost benefit equation is going to be in favor of HPC. Mm. But then you're so ingrained in the cloud enviort that you're sort of...
You're partly locked in because you're using that tech stack.
You are locked in on the one hand, technically, or sort of organizationally or operationally, but also because like you're just running, right? You're building a company, you're running like hell, and then... Can I say that on a podcast? Yeah. We're not Americans, so it's fine. So you're running there and you're digging where you are. But this is a completely different way of training.
But I think it should also be frank that these kind of like top cloud providers, they have an amazing service. I mean, they are self-service to a large extent. You can actually get started very, very quickly, very, very easily. Yeah. Awesome documentation, awesome, support and everything, which is hard to compete with. But as you say, the problem with them is that it becomes really, really expensive when you actually start to scale something up. So
but it's like we discussed with the chips, right? That you have this ecosystem of support and services, which is really great. Yeah. It comes at a cost. And that cost is a no-brainer at a smaller scale because you can't afford to have all of this stuff in-house. Right. But at some point, if you're training really, really large models, or if you're using a lot of GPUs and CPUs, core hours,
or if you want to in the future, if you have an idea how to scale up, if we only had so much more compute, what could we do then? And then HPC becomes a factor.
Yeah, we've been discussing with some SMEs who are like, if we had that, we could do all of these things that we've just discarded for now because it's completely economically unfeasible to do it.
Right. Can you elaborate a bit more? Do you have some example, perhaps, businesses or projects that you are focusing on, or what would... like the stereotypical favorite kind of SME be that should contact, ENCCS and hear more about their potential?
We've been focusing a lot on AI SMEs lately. through
what on AI?
AI SMEs and startups.
Yes.
Through Ingrid's connections and her great work over the summer. And it's been super interesting to get to talk to these people. And
when you say SMEs, how large type of company are you speaking about?
I mean, we use the European definition because that's what we have to adhere to in our work. I mean, we can do certain work with SMEs, which for free, and the proof of concept projects are restricted to SMEs. And the definition is, the European one is up to, 300 people or something? 250. Which is
employees, right?
Employees, yes. I think there's a number on the total turnover or something as well. I'm not sure. Yeah.
I mean, you can still access these resources as a larger company as well, but the terms might differ slightly.
Yeah. And SMEs have other exceptions too, just to take that detour. So, I mean, we're supposed to focus on the SMEs, and that's what we want to do because that's where we can make the most impact. The big company can do their own thing. They can buy own hardware or what they need. SMEs can't. So there are these exceptions. We can support them extra much. And they also can get exceptions to the open science requirement for EuroHPC access.
Okay, so there is otherwise an open science, basically an open source license saying that the science should be open for them to use it? Or?
Well, it's not so precise as to specify, that everything should be open source. But there's like explicitly written somewhere that work done on EuroHPC should be as open as possible, but as closed as needed. And that in particular for SMEs, you can...
yeah, but it literally says like you might need to sort of loosen the requirement on open science if it's in the interest of the beneficiaries being the company who's using the resources. And they're also exemplifying that this could be, for example, for competitive reasons or data privacy reasons or stuff like that. So it's not that you have to publish everything you do, but I think the general thing is that we're giving you resources. It's good to know what they're used for. And if there are any learnings that can be shared in the wider community.
Just to have some company out there, be identifying with, this is something that could be useful for me.
Yeah, I didn't finish the story about the types of companies we worked with. I mean, we had contacts with companies in the past, many of them, some big companies and some smaller companies. There were already AI companies we spoke with 2 years ago, before the LLM hype and everything. There was a company doing speech synthesis, text-to-speech, another one doing battery inspection with computer vision, and they used successfully EuroHPC with our help. But there were many companies as well doing the traditional HPC domains like computational fluid dynamics and electronic structure calculations, molecular dynamics, biomolecules. Yeah. But it's really been an acceleration of contacts with AI companies lately. And I think that's a good thing. I mean, that's certainly the signal we get from above. Find your AI SMEs nationally. I mean, message we hear, and it's directed to all the national competence centers in this network that, focus on AI.
In my very subjective view as well, I think Europe in general, at least in the last 10, 15 years, has had far too little focus on AI versus like US and China, of course, put much more effort into it. Do you think that's something they are trying to remedy now a bit by actually putting more focus on AI, or would you say it's similar to what it has been in the last 10 years in terms of investment in like AI related?
Well, my impression is that it's accelerating. I mean, it's really a higher level of ambition now than it ever was before, exemplified by the AI factories, and making the EuroHPC machines, currently existing ones and future ones as well, more usable for AI companies. Another example of this is that, when you apply for EuroHPC, you can choose different tiers, smaller tiers, which are really easy to get. You just write a small technical application evaluated by one HPC expert on a technical basis. And then there are bigger tiers, going up to extreme access. But recently, EuroHPC introduced the AI and data intensive access for...
Once again,
AI and data intensive tier to EuroHPC.
Okay. To make basically for these use cases, try to be as smooth as possible for these use cases to
Yeah, I mean, it doesn't affect really how usable the EuroHPC systems are themselves. It's about the
administration.
The administration, how you apply and so on. I mean, and the whole atmosphere in Europe, in EuroHPC, and the Commission is to facilitate as much as possible AI companies to get to accelerate, I mean, to grow as quickly as possible. There's really a lot of focus on SMEs and in AI.
And you have given a cliffhanger now a couple of times here. What is really the compute? What does it continue?
Oh, continue. Well, I don't know who coined the term sometime in the past, but it's adopted by our brilliant colleague and friend at RISE, Johan Christiansson, who has this vision for the future. So he comes from the cloud. I mean, we're comparing cloud to HPC all the time now, right? And it's a very pertinent, very relevant comparison to do. And he comes from a cloud background and realized the importance of. So he sees the complications with cloud. You have hundreds of different services you can find from these different cloud providers. And then he, through research at RISE, there's lots of research on edge computing. And with us, ENCCS, when we came into RISE, there's again a focus on HPC. And the this smorgasbord is just growing, right? And they're all distinct. They all have their own distinct qualities and complications. We need something to glue it all together. And the future vision with the compute continuum is that compute should be like a commodity, like electricity. You plug something in the wall, you get electricity. You should be able to do the same with compute.
Amazing vision to have.
Oh yeah. And as a step in that direction, he has been developing single-handedly a very cool framework called Colony OS. It's a meta operating system, which is Colony OS.
Colony, okay.
OS as an operating system. I mean, it's more computer science than I care to know, but there's lots of ingenuity in this platform, and it's meant to abstract away all the complexity of the backends. I mean, you can keep data in cloud S3 or something. You can run certain lightweight things on your own computer or your on-prem whatever cluster. You might have edge nodes, and then maybe you have a part of your workflow is compute heavy, R&D related, whatever. It needs to run on HPC. And this framework can orchestrate and automate a lot of things. And this is not an old idea. There are not a new idea. There are many projects that have been started, and not many have actually reached anything. But this is production ready. This is already in production in Sweden, yeah. And it's something we're looking for potential interested parties in trying out. I mean, in actual production.
Because in some way, if you see like the top scale kind of compute project, take LLMs or whatnot, they seems to be, super optimizing a very more and more specific compute projects. Like, for large LLMs, you need to have a super high bandwidth. It's not really flop limited anymore. It can be more like the bandwidth with limitation, because they need to send the gradients around to such an extent for these large models that it's actually limited by bandwidth rather than compute potentially. And they seem to be optimizing everything and making it work only for transformer based and only for this very specific use case. And this one is going in the other direction, which is, I think, is interesting. I think both should be, interesting areas of research. But would you agree with it that some kind of movement is just saying, how can we just make this work for this very, very specific use case?
Yeah, I mean, it's all moving into more heterogeneity, more variability of different platforms, different architectures, optimized for different purposes. And we're only seeing the beginning of it, I think. I mean, that's a whole new topic that we might go into, but Europe wants to become sovereign, wants to become independent in hardware also, right? Yeah. So not relying on the big hardware companies in the world, but actually having homegrown technology for CPUs and GPUs and so on.
But we're talking now about a push from the chipset to the computer, to the data center, the infrastructure hardware, and then we want our software and SaaS companies as well. I mean, like, so this sovereignty goes across the board. Yeah. This topic.
Yeah. So, but the point I was thinking about was that, the heterogeneity, the variability of different hardware is only increasing, and there will be customized chips, customized FPGAs. You might have quantum computers in the future, which might work well for certain workloads. And you need some way to orchestrate all this complexity, or manage the complexity and orchestrate workloads across.
And this heterogeneity, is that a given trend? Is that a given that is the right path? Is that obvious? It's just like a law of evolution of the use cases, or why are we going
that's a very big question. And
is it good or bad?
It's feels to me to be unavoidable.
Yeah, this is what I mean. Like almost like the genie is out of the box. Like it's a law of what we are doing now is leading down this path. I
mean, one driving force behind it is, of course, efficiency, energy efficiency. You don't want to train AI models on CPUs because it's more it's more efficient, it's faster and more energy efficient to do on GPUs.
I think boom, you put your finger on it. Maybe one of the most important topics here when we talk about energy consumption. And as we're saying, should we have the huge mega models for everything, or do we need to have ensembles of very small models? And there is something the cost and the energy footprint is sort of driving us to be efficient in what we're doing.
Yeah, I'm going to stick my neck up and say that I agree. I mean, I think. I normally, because I work a lot with also people who aren't that into AI. And for people who aren't in AI, LLM has made sort of AI accessible for everyone, because suddenly you can talk to an AI with human language. So you use them for everything, like what should I cook for dinner or whatever. It's great. And talking about AI, a lot of people are now just talking about LLMs or Gen AI. But to a lot of applications where the data or what you want to do is not necessarily natural language based, then using an LLM to get an answer is like going with an aircraft carrier to get sort of small fishes, right? You're using a lot of energy to get something fairly simple out because you want to be able to use natural language, but then you have to have like an insanely big model to translate that into something that the computer understands, to make a very simple calculation and then translate it back to you using a lot of compute again, which is extremely inefficient. I heard somewhere, and I haven't checked the source, but I have heard that prompting ChatGPT could be like take as much energy as charging an iPhone.
Interesting.
I'll have to double check that, but it's something I've heard several places.
I love these kind of metaphors.
And it's like, and even if it's not that much, but I have heard it from several sources, but I can't remember which one, so I have to add a disclaimer there. But it's like, it's not just like turning on a light bulb for 5 minutes. It's actually quite a lot. Yeah. And then you do like these super simple things because you can. I mean, it makes no sense. And then you have these newer models like the 4.0 and the 4.01, for example. And then you kind of see that they might be trained to be a lot better at some things. But then going back, like the GPT-4 might be better at like super general things because it's not as pruned and it's not as specific for performance on a certain set of tasks. It's just like super general. It just calls the entire internet to be able to give you like super simple answers on a question because it's just general. So
there's actually a funny analogy here between like a CPU, the general purpose processing unit in a computer, and the super big LLM, which is rather good at everything. But specialization is key maybe to energy efficiency and
So it seems like we can sort of draw a generalization here from hardware specific, being efficient specifically, all the way up to how we use different types of machine learning versus, So it seems to go in the same direction of efficiency.
If you take an analogy, a team, say we're a team, and if we all have the exact same competence, so we all can answer to every question that comes into the team, then we have to know a lot more. But if we specialize, we'll be able to cover a lot more grounds because we can just direct questions to each person, right? And it's the same with compute. If you have one model that has to be sort of the silver bullet and have, the answer to everything, it has to be so much more powerful. But if you want to dive into a specific domain, then you want to have a model who's specialized on that domain. It doesn't have to be a specialist on everything else.
I think that's a super interesting topic, and perhaps we can move to that.
Let's go there now. Let's go there.
And for one, I certainly agree, of course, what you said, the generative AI hype that we have there. People that are now calling themselves for AI experts are in reality just ChatGPT so-called experts and don't understand that AI has been around for 70 years and there are so many other AI techniques than LLMs that are super useful, and then you need high performance computing to train them, and you can't use LLMs for everything. But was it Oliver said something, there was a news about XGPUs 2.0 being released, and the comment or the meme was, I haven't heard about that LLM. It's kind of super fun kind of analogy. Yeah. But also, if we just expand this question that we spoke about and try to think like a couple of years ahead in the future, we can at least see that the frontier kind of foundational models are increasing in size. And potentially fewer and fewer companies can at least train them from scratch. I mean, even with Lumi at hand, it would be hard to do it today. And then if you just try to extrapolate a bit in the future, I think even using them in the future will be so expensive that it won't really be feasible to use at least like the largest O1 model that we have in the future. So then you do, I think what you just said, Ingrid, create more and more specialized models. So perhaps you use these kind of large foundational models to be a teacher for them and a starting point, but then you fine tune them for your own data that you haven't seen and for your very specific use case. If that is a baking recipe or, trying to understand X-ray images or whatnot. But that could be a future, right? And that can be a way for us to have the need to use like EuroHPC and these kind of AI centers, even if you can't build the biggest one, so to speak, right?
Yeah. We don't have 200,000 GPUs like X has, but we have enough to actually do really useful stuff.
Yeah.
I think what's interesting about these huge models is that they're able to learn from different fields. And I mean, we saw, it was a while back now, but when we saw the first ChatGPTs was that they were able to sort of draw conclusions from one field and then sort of understand physics or something like that. So they can learn from different fields, which then like if each learning from each field can be applied to all fields, then of course you accelerate learning. So I think to have a few of these large models is going to be great to kind of push the frontiers and also understand where does it make sense to build specialized models. But it's not going to be it's probably not going to be the ones that we normally use. But it makes sense to have also maybe one in Europe and not just in the US and in China, for example.
We would love that, I think.
But I think this is a huge topic because everybody's sort of, let's go home and die. We lost the race, right? It's all over. It's not.
Who says that?
Who says that? Because all of a sudden now we are realizing that, okay, there will be some super big, very few of the biggest of the kind. And they will have but in the end, it's almost like they're going to be pushed back. And we're going to use them in order to train the models that are then done in Europe for maybe automotive or maybe an applied research field or an applied business field. So it means that how this market will structure itself and where the opportunity lies for Sweden or Europe to actually be best in the world, competitive. It's still an open field when you start understanding where this is going. And this heterogeneity topic, this data continuum topic, when you get your head around that, now we can see, we're going to be the best on applied AI in Sweden or in Europe. Okay, here is what we're going to play. I think this is a quite feasible conversation, strategically where to go. I don't know. What do you think?
Yeah, and I think also, and now I suppose I'm going out on a limb here, but I suppose if you have a lot of different or sort of diversified models and you have this compute continuum, perhaps you can kind of get the same effect that you learn from different fields using sort of an overlay, if you will. I don't think that we should sort of disregard that being in the race of having, these large foundational models in Europe as well is probably quite important for longer term competitiveness. But like I said, I think less and less of actual work or production is going to be on those super large ones, because it's not energy economically feasible.
And I think it's also interesting to the inference cost. Even if you use like APIs and pay the cost it has there, it will still cost quite a lot if you start to put it in production and use them extensively. So then you perhaps need to train or fine tune your own smaller model that is sufficiently big to work for your use case and also economically feasible to run. Right?
Yeah, it feels like...
And you can find a niche here, so you can basically find a position in the market, from the product UX to, where is compute done, where is the majority of the compute really done, to train the model over here, but in inference in production, maybe in a completely new segment. Yeah, interesting.
Awesome. I think we should have a potential small break here. What do you say, Kirill? Do it.
Let's see. He has removed it.
No, but we usually take a small news break in the middle of the podcast to just speak about the recent news that we've seen and been interested in like last week. And there's been at least one super big one, but let's go around the table and see what kind of news article would you like to speak about. Thor, would you like to start?
Yeah. Well, we sort of already talked about the AI factories. I mean, that's very important to our field, to what we're going to be focusing on in coming years. And that's exciting for us. And but it's sort of, we'll see where that leads.
But that's something that ENCCS will also spend time on?
We will play a key role there. I mean, SMEs, companies in general, startups are going to be important stakeholders and recipients of services from these AI factories. So we are the natural partner there too.
And when did the call actually come out? And when was it?
Last week.
Last week.
Yeah,
so this is news.
It's a super news. Super new news. Yeah. But maybe it's fun to raise something slightly more technical, geeky. Which is closer. Also, I mean, I'm not an AI expert by training as such, but I read an interesting article about Kolmogorov-Arnold networks, CANs, which was fascinating to read. And then I saw that it actually came from Max Tegmark's group at MIT. So that was pretty cool. I mean, fellow physicist who turned AI expert and, AI safety evangelist and so on. But
doomer.
Yeah, that's another way to put it. So that resonated with me because it's physics. I mean, it's not going to be... So, okay. CANs, Kolmogorov-Arnold networks, replace weights basically in the networks with functions, and it's different mathematics. There's a different underlying formula for the expected efficiency of these networks. And what I found interesting is that you get explainability, better explainability. You can. It's not a universal. It's not a model that has use cases across the board. It's not for language modeling or whatever, as far as I understand. It's for like modeling physical phenomena, for understanding physical phenomena, solving mathematical equations, finding mathematical equations that describe certain phenomena. And they offer potentially more interpretability, which any scientist would want. I mean, you don't want black boxes, you want understanding as well.
I think it's a super interesting field of research. It was some time that I read about it, so my memory is not perfect about it. But in short, it's just replacing this kind of super simplistic relus, this kind of function that is simply having a inflection point. So it's either 0 or times 1, so to speak, with more advanced functions and thereby being able to reduce the number of parameters that you need to have. So, trying to understand and have an explainability for a model that has billions of parameters in it is not easy. But if you can instead have more advanced functions, then you can reduce the number, and then you can start to see that, okay, I can start this part of the brain or the network is doing that. Yeah,
so you get more information somehow in each node, I guess. I mean, so it's not just like a number between 0 and 1. It's something that you can more easily understand. Which
was it? There's like splines and these kind of different lines connected with some kind of spline type of function or something.
Please don't ask about details. I'm beyond my comfort zone. Yeah.
I think it's.
But it's cool. It's cool. And Max Tegmark is working in MIT, right? What is his team? Do you know exactly what the main focus is of his team? I mean, like we know what he has been talking about.
Yeah. I mean, he's a cosmologist, hardcore, theoretical physicist, turned AI expert. And I guess I haven't looked into it, but I guess he has a pretty big research group.
Yep.
Probably half of which does physics and the other half does AI. And
I think one of the focuses that his group is having is this kind of mechanistic interoperability. So it is the explainability part, as you say. So they spend a lot of time trying to see if they introspect the actual parameters of a huge network, can they see, what the different nodes or parameters and the weights in the model actually do. I think one example, if I remember correctly, was that they wanted to find, is there a part of the huge large language model that has the city of Paris encoded in it?
But wasn't it Anthropic that published something about that in, I think it was like May or something, early May, where they trained a model on like San Francisco or something, and they made it sort of, and they honed in on a specific part of the model, and then suddenly it will bring in San Francisco and everything. It's like, oh, what's a good recipe for like a muffin? Yeah, you get this recipe and it's best enjoyed viewing the Golden Gate Bridge.
It gets obsessed with San Francisco.
Because they place more weights on the sort of San Francisco part of the model, or if it was Golden Gate Bridge part of the model.
Yeah, but that's the sort of reverse engineering you have to do to understand a traditional model, right? Yeah. And hopefully there are these other types of models, other architectures that offer more explainability, which might be important in some settings.
Yeah.
That's a cool one.
Okay, I should speak more about that. I think, explainability is super interesting. I don't think, mechanistic or this kind of introspection into parameters is the way forward. Just as you wouldn't, if I were to understand Henrik, I wouldn't, drill in his brain. I would try to find some other way of.
Elon is doing that, though.
Sorry?
Elon is doing that.
Yeah, but not everything Elon is doing is right.
You have a point there.
All right, so let's go to
again. There's a use case for every approach.
But let's go to the next topic. Ingrid, did you have a topic you wanted to bring up?
Yeah, I think, on the topic of explainability, but going more into language, I think it's worth mentioning the GPT-4o1 model, where it's basically got more reasoning capabilities.
Sorry, Ingrid, I just understood you. I misunderstood you previously. You mean Neuralink kind of work Elon is doing? Is that what you were? Yeah, okay.
What did you think I was doing?
No, I thought you meant that Elon was doing actually AI network kind of introspection things.
Oh, no. I meant
he was drilling into people's heads.
I got the drilling part.
With a drill.
Yeah. But I still...
Did you see the news story about that when they had the first human trial?
Oh, yeah. But that was a couple of weeks ago.
Yeah.
But it was going so well, though. Like, everyone was surprised. And the funny thing is, it was like, I thought I'd be so much more productive, but I just stayed up gaming for 8 hours straight.
And he was playing. Okay. Yeah. I think this is.
Let's take that news. Let's take that news. We haven't taken it here. This is news for us.
I mean, it's to what I recall, basically, for some years now, Neuralink has been building these chips. You actually embed them, operate them into the human brain, and you have this kind of 1,000 threads that you connect to neural cells in the brain. Neurons.
Yeah.
And then they had now the first human trial. So a person that had, he was in some kind of accident and he couldn't move anything.
Yeah, right? I think he was in a surfing accident and he was quadriplegic, which basically means that 2 arms and 2 legs can't work. So he was like a vegetable.
And then they put the chip in the brain to keep it short, and they connected it to a computer so he can control the keyboard and mouse or something.
With his thought. So he's controlling the mouse pointer with his thought.
Yeah. And then he plays games to an extent that basically like human expert or world level expert. Not because he doesn't need to use his hand anymore.
Not hampered by
he can control the
hands and arms.
Exactly.
Yeah, and what they realized was that he was like, but it's moving before I've thought it.
Oh.
Because normally, like if you want to move your hand, like there's a slight delay.
Yeah.
But if you're just thinking it, then it was kind of before he understood that he made the thought.
I hadn't thought about that, but that's super cool. I mean, because you only become conscious of what you're actually about to do, like half a second or 200 milliseconds or something after you actually the thought happens in the brain.
You send an order to lift your hand, but the order takes some time. But if you don't have that latency,
and then your brain autocorrects, it makes it feel like synchrony.
They have to check, I guess, in the future if you have esports that no one has a chip in the brain that controls the mouse.
But so what about this interface though? Just because I'm curious. I mean, there must be AI involved there to actually translate the signal.
Yes. Yeah. They have a network that's trained on that.
And it's based on reinforcement learning. So basically, when he uses it, it becomes better and better at understanding his thoughts.
But this was a couple of weeks back, right?
Yes.
Yeah. But the point with the GPT-401, to go back to that, I think the point there was that because normally, like with the older version of ChatGPT, you had to be quite good at prompt engineering to understand that, or to get really good response. And what people discovered was that when you're prompting for a chain of thought or you're prompting for reasoning behind a reply, you get a better response. But this one has that built in. And then I was following, so we have a quite active Slack on Stockholm AI, and that's where I get a lot of like the really good drill downs from my friends who are reading a lot more into the weeds than I am. But we had a lot of debate on whether sort of this was kind of an agentic thing, that they're just like having agents prompted for chain of thoughts. But apparently it looks like that's not the case. Because it's, well, first of all, it's not multimodal. And also there are challenges to what you can do. Like you can't set parameters in the same sense and you can't drill down into it in the same way. So basically it's just reasoning itself, which is quite cool. And that's also kind of democratizing because like one pointed out that very few users of ChatGPT know this hack about prompt engineering, for one, but also like getting this chain of thought thing to get better results. So
I can speak about this forever. I'm trying to clarify my mind to speak about it briefly, but I think one way, at least I try to explain, I think the big news that I think this is one of the top AI news of the year, I would say. And the reason is, if you take a thing like AlphaGo or AlphaZero, like in 2015, it could play chess, Go, StarCraft, or whatever, and it does so better than any human ever could. And if you take AlphaZero, it did so without even looking at any human data at all. Yeah. It generated its own data. And this is actually close connected to what we're seeing now with O1. So O1, it was, previously connected to this Q star, and Q star can either be Q learning kind of optimal policy kind of connection, but it can also be connected to this paper called STAR, self-taught reasoner. And it's also connected to this reflection tuning that we spoke about last week. But in short, it's about generating reasoning, a motivation for how to come up with an answer. So chain of thought prompting is one way of doing that, but it can also then say that, okay, if you want to have this kind of answer, do the reasoning to get there. And then you can check if it's correct. If it's not correct, it can actually fix itself and have reinforcement learning saying this was actually right or wrong. And it can learn to do the right reasoning. And it can do the reasoning without any human giving it the reasoning. Yep. It's self-taught. Yep. This is actually a big thing. So similar to AlphaZero, it can actually simulate forward how you should play chess, for example. In this case, it can actually simulate itself how we should do the reasoning to come up with an answer, which limits the dependency to have human labeled data or even having data at all. It can actually create their own data itself.
Do you think it could play chess at a high level?
No, not it.
No, I mean, chess. LLMs were tested for chess.
Yeah.
And it actually could make a few reasonable moves, and you could put up the position on a board and it sort of made sense. But then craziness happened.
But I tested it directly, of course, then it came out. And I did, one of the first, simple things that GPT-4o couldn't do well is simply count the number of R's in the word strawberry. It's a famous example. And of course, now it can do this correctly. But another question that GPT-4o and all other LLMs have a hard time trying to answer is, give me like 10 sentences, each ending in the word fusion or something. And surprisingly, they can't do it. And they can give some sentences, but at least a couple of them is always wrong. And you would say, as a human, it's super easy to do. You can just list the word and you can see directly, this is not ending with fusion. I see this is wrong. I tried it on O1 and it failed. And then, okay, I understand. It's not at all the level of reasoning that, of course, humans have, nor does it have the type of reasoning that AlphaGo or AlphaZero had. It's increased reasoning for sure, but it's not at all to the depth of reasoning that humans or these kind of AlphaGo kind of systems have. But it is a significant increase. So in short, just as Demis Hassabis has said himself, what they are working with, in Gemini now is to take the traditional type of LLMs that we have and connect it to AlphaGo. That's literally what their research is focusing on right now. They haven't done it yet. O1 is a first step towards that, but it's not that big a step, I would say.
It's like they call it O1, I guess.
Yes.
Yeah, but it's also interesting how they are quite clear now that this is complementary, and they are putting out these big statements on this is useful in these particular instances and types of use cases, but we recommend you to use 4.0 for this and this. And what were the examples that they highlighted where O1 was the preferred, more complex tasks was the general
data analytics and math,
data compute,
but
programming. Yeah.
O1 doesn't have the capabilities that 4.0 has, and so it can't search on the web, which 4.0 can. It can't work with other type of modalities, images, for example, at all. So there is a lot of limitations that O1 has because it's the first version of something completely new.
Yeah,
not completely new, but rather significantly different. In short, this would be GPT-5 if they continue to do the proper kind of versioning on this, but they chose to, completely disconnect it from the traditional kind of GPT-4 naming and now call it O1.
But wasn't there also an idea here that it should be able to generate its own training data now?
But that's what it's doing. So it's generating the reasoning it's generating is its own data, right?
Yeah.
That's what's so amazing. It's exactly like the AlphaZero. It can actually generate its own data and train by itself to improve. So in this way, potentially in the future, it can continue to improve its reasoning skills without having the dependency of humans.
Which is possibly terrifying.
Yes, it is. And there's also some kind of IQ score measure. I think all of the others, if you take the best one, I think Claude, is in the top and 4.0 is in the top, but they are around 100 in IQ score kind of measure. 100 is the average of all humans. And then it's like a bell curve from that. This one was 120.
Okay.
So significantly better than the average. Yes.
But is that the right way of measuring it, though?
No.
I was listening to Harari made a speech. I think it was just before summer at this Future Talent Summit here. And he said that it's like measuring AI models in terms of human intelligence is kind of like measuring how well a plane imitates a bird.
Yes.
Or something like that.
I use that metaphor as well. It's a great example.
I think it's quite, and I'm not sure, but I kind of also feel that it doesn't have to be like a human to be very useful. We don't have to measure it with IQ.
I think this is spot on reflection.
Because I also feel like, we sort of come up with a definition of intelligence, air quotes, based on what we know as humans. And then we set we say chess. And then the AI can play chess. And then we're like, yeah, but it's not really as humans. And then it's like, oh, it's with, natural language. And then we build models that can handle natural language. And then we realize that, it's still not as general as humans. So we kind of push the boundary because we don't really know what intelligence is my feeling. Or we don't really have a good definition that we can measure an AI based on. Because IQ tests
I mean, like that, it goes to humans, right?
Yeah.
Who's the most intelligent? Michael Jordan in basketball or the physicist?
Exactly.
I think it goes back to like specialization again.
Yeah, IQ score is bad both for human and for AI to measure the score, but it still is an interesting measure. I mean, if it truly is an AGI or a super intelligent, it should be able to master
Some
that
sort
as
of
well.
benchmark.
Yeah, exactly.
But it's certainly not
It's a hygiene factor, but not necessarily.
So, I mean, we know that even LLMs are significantly better in terms of knowledge than any human ever can be. And for AlphaZero, it's insanely better than reasoning that any human ever can be. So it's easy to see measures or ways to try to measure intelligence or knowledge, which is not where humans are simply bad.
But I really like that simple metaphor, with the comparison of the plane to the bird. I think it's telling, right? Why are we trying to push the plane into being a bird?
It flies as well.
It flies as well, right?
And I think that's also what Geoffrey Hinton, alluded to when he said, he invented the back propagation, back in the 80s, and he said he did that because he wanted to understand how a human brain works. But he said, I know it's an approximation. I know a human brain works differently, and I know it's very limited. But at least it's some first approximation with a back propagation to try to train up some kind of neural network. But now when he, quit Google a couple of years back, he basically said, I believe that backpropagation is potentially superior to the human brain because it can learn much faster than the human brain can. Mm-hmm. It's just because it's different from the human brain doesn't mean it's worse. Actually, it can be that the backpropagation algorithm is actually better.
For some use cases.
We know the human brain is significantly more energy efficient, for sure. But if you have a lot of
back
energy...
to that learning, how? I mean, we learn from very few examples.
I mean, just take an LLM, you basically can ask it any question about any topic.
Yeah, it has much better recall.
Yes.
Yeah.
Yes.
I mean, we do learn from very few examples. We're kind of initiated, though, with sort of a gene pool that has been developed since, the beginning of time. You can sort of see that as a sort of
pre-training.
A long pre-training.
Long pre-training phase.
Yeah, exactly.
Spanning billions of years.
Yeah,
billions.
So I think it also is a little bit difficult to say, it's better or worse, because also like the sensory input we get, yes, we have eyes and ears and nose and mouth, but we are also like our entire bodies has some kind of sensory hierarchy as well. Like with the autoimmune system, for example, I don't feel, for example, my stomach normally. But if something is wrong, I will feel it. So there are sensors there as well. It's just that it's lower in the sort of attention hierarchy. So we get a lot of data.
Yeah. And we got to all these rabbit holes from the news of O1. But it's a big one.
It's a big rabbit hole. That's a big news.
But this is why it's like a news item that is so interesting that we can sort of flip around in many ways.
I think it's also interesting. They released like 2 models out of 3. The big O1 is not released. O1 preview is released. And they have the small one, which I think is interesting and connected to what we just spoke about before.
The mini.
Yeah, the O1 mini, which apparently is really good at coding. So a bit more specialized, also what we spoke about before, but is significantly smaller and cheaper to run.
Okay.
So, I mean, I think, they have extreme inference costs right now in OpenAI. So they need to have a way to run certain type of tasks much more efficiently, and by having more specialized smaller models like O1 Mini, they will do so. So I think it really moves in this direction that we just spoke about.
Yeah, I think that's interesting how it's a trend here. We can see it.
Come full circle.
Full circle on our own analysis. But maybe, do we have some more news, or should we end it with that?
Yeah,
I think it's enough. We went on a tangent with the O1, so I think we stop with the news now.
Yeah, sounds good. Okay, and the time is flying away, and we want to try to keep it to 1.5. We won't make it, but at least under 2 hours. But perhaps you can speak about the next steps. What's coming up for ENCCS, and you already spoken a bit about that for the AI factories, etc. But can you elaborate a bit more? What's coming up?
I mean, our ambition is to grow, to become more visible across the spectrum in Swedish industry, but also public sector, even academia. We are involved in consortia, applying for grants, different types of grants to expand sort of peripherally or in adjacent directions from our core activities in HPC, and they have to do with AI, they have to do with quantum computing and so on. So we want to build a bigger group of experts who can help a bigger group of companies with more diverse use cases. And it's a very interesting environment to be in because it moves very fast. I mean, things happen quickly. I guess you're very used to a dynamic environment in AI, but also in HPC, a lot of things is happening. And we want to expand our training portfolio, not machine learning training, but human training. Yeah. So But
if I get it right, this sounds really smart, by the way. Am I taking you right that you want to expand the ecosystem around yourself? I mean, I immediately get the neural pops, like, oh, that's how SAP is doing it in order to get the ERP out there. They have millions of certified management consultants, or so is that one of the parts now to in order to grow and become sort of a established player and get critical mass? It's you need to grow, but you actually need to grow the ecosystem around you. Is that
the ecosystem is growing without anything from us. I mean, we're a small player, but there are increasing investments, and the national competence centers that we're one example of is just one out of multiple different beasts in this EuroHPC ecosystem. There is also centers of excellence that focus on different domains, so bioscience or material science or catastrophe prevention or modeling, stuff like that. And
so these center of excellences, are they part of the EuroHPC?
Yeah, I mean, the word center of excellence is probably used in many different contexts, but there are the EuroHPC COEs, and we collaborate with them.
And just to understand, if you compare like a competence center to a center of excellence, what's the difference?
So each country should get a national competence center. So there's an NCC in 32 different countries. Yeah. But there are currently, 10 or so currently active COEs, but they are multinational. They have partners from multiple countries, and they're focused around a certain area, domain.
Applied area.
So a domain where HPC is relevant. And
COEs are larger than competence centers in general, and they collaborate across the border, the country border, so to speak. Of course.
And we collaborate. I mean, we belong together in a sense. And the NCCs and the COEs, we're tied together in this ecosystem. And we actually have worked with one of our clients, quote unquote, again, they don't pay us, but we call them our clients. They came in with a use case to us, and it was a very interesting use case. We could help them get access to HPC, but they also had a need for certain expertise. So we connected them to a COE, and they now have a beautiful POC going on, which is all about actually improving air quality in Stockholm. So we work and thrive in this ecosystem. We want to grow in the ecosystem, and the ecosystem itself is growing.
I was also getting a very concrete view of like we're talking about business development around this. So if you look at learning from software, one of the key critical strategies for a new vendor to get out there, like you have a new app, you have a new software, you're growing the ecosystem of different types of partners, consultants doing different things who can sort of connect from the customer into the actual, using then HPC. So you basically end up to having a lot more touch points or sort of tangents or, so there's a lot of, I get this whole vibe of, you could do that could be an interesting area when you say ecosystem, also to, how you can attract other partners in order to do the sort of evangelizing for you.
So two things to say. Maybe one is that, we are offering this free access to HPC. It comes with some requirements. It has to be open in some sense and so on, but it's free. So cloud providers might not like it, but in a way we're not competing, or we're creating a market where there isn't a market before. We're creating a market for scaling up, running bigger things. And EuroHPC might not be free forever. There might be a time when you start paying for access. But the goal is to by EuroHPC and the NCCs and so on is to help these companies create business models based on HPC and become more competitive as a result, and be in a good position later when things might start costing money and so on.
So is there an exit plan for ENCCS, saying will you continue to get money from EU, or will you at some point need to have your own funding covered?
Yeah, so we're one of our side focus areas is to look into ways to become economically sustainable.
Okay, interesting.
In whatever way that could take, it's unclear, but that's certainly something on our radar. I mean, there will be a EuroCC 3 project, most likely. Yeah. Probably EuroCC 4 after that. These are, of course, run as projects. Everything is run as a project. Yeah. But there's still the will to make something permanent here.
Because I think bottom line is to create a market, and to create it is sometime it needs to go from being, in quotation marks, superficial to sustainable.
Yeah.
Maybe, I don't know.
I wanted to add also one more thing, which is a joint NCC effort. I mean, multiple NCCs across Europe are involved in working out the specs and requirements for sort of like a marketplace platform or a LinkedIn platform for HPC. Of course, we have already LinkedIn. We could use LinkedIn, but to create
a community
around HPC where you exchange information, you post your open positions, you advertise your HPC services, and so on.
It's a marketplace thinking.
Yeah.
Very interesting.
Where everyone is invited, right? I mean, we have the free academically supported projects. The CWEs mostly are academia. NCCs are often hosted by universities too. We're funded to help for free, but you could have commercial players coming in and they offer different types of services with different...
I mean, if you are talking about a gap between traditional companies who potentially could have a huge calculation need, but they are not really tech savvy or mathematically savvy or HPC savvy. So of course that becomes an opportunity. How we close that gap.
Yeah, and just maybe final thing about ecosystem. I mean, we work in this level of the stack, HPC. Not everyone is ready for HPC. Absolutely not. In many cases, it's enough to buy a beefy laptop and run everything there. That's perfectly fine. And in other cases, the challenge is to digitize, to move away from Excel spreadsheets into writing Python code or something. We're not working there, but there are other European projects and national initiatives as well to help with those aspects. And, in our ecosystem, once again, we have the European Digital Innovation Hubs, testing and experimentation facilities and so on. So it's like a smorgasbord of different projects which somehow work together to...
A problem I have a bit with all this EU funding here is it's so much focused more on innovation R&D and not on a sustainable business model. I mean, if you take, for example, large AI models today, it costs money to train them. But if you have a big company, it will cost much more to run them. The inference cost will be higher. And this is not something that, the ENCCS or other kind of EU funding today is trying to cover. And I think it's a bit problematic. And I think, if companies should be feeling like a proper support is not just for the R&D part, it's really to build up a proper business that support them throughout, Do you have any thoughts about that? Or
you first.
Yeah, I agree. But like we said, HPC is one area, and that is more of an R&D environment. So by itself, you wouldn't have a business that only does HPC, most likely. So I think, but there also, I think these programs, I want to kind of view it as a little bit of a freemium model. If you start using a EuroHPC machine, you're not required to continue to pay for it. But I think an ambition with these EU projects should be to have SMEs or companies that have use for it understand the business case for using HPC, so that you later on can also motivate actually paying for it.
It could be an accelerator in that sense.
Exactly.
Precisely.
And so, yeah, it's sort of supporting R&D, but it's supposed to be supporting SMEs for whom their product requires some R&D. If your product doesn't have, like, it's when we're looking at which SMEs might have use for these resources, we will be looking at SMEs who have sort of data scientists or computer scientists or research scientists, so that which is kind of an indication of that they're actually doing some more scientific R&D. Because if you just have sort of data engineers and machine learning engineers, then they would normally be working more closer to the production environment. And then it doesn't make sense to kind of try to break out stuff to put in an R&D environment, because that's not how those companies work. So
I think I should mention just in this context, because it's so on topic. I mean, there are the free HPC resources and so on via EuroHPC. You can also apply for funding. There's a funding program called Fortissimo, or FF. FF Plus is the most recent sort of incarnation of this ongoing funding scheme, where you can apply for funding and compute time. And there are two different tiers. One is like for people that already use HPC to scale up and so on. The other one is called business experiments. So people, companies that are looking into changing their business model, expanding their business model, coming up with new models based on HPC. So you can get the funding actually to kickstart the journey into a new business model.
We're at the end going to throw all the money into American, cloud providers, and it's a bit sad. I think that we don't have any more Swedish or European.
Yes.
Yeah.
And on the more short note, why don't we do a shameful plug? What are you doing next week? Don't you have a conference coming up?
Indeed. Well, we had the conference in Copenhagen early September. That was great. We worked with our Nordic colleagues. We had we were in the venue of Dansk Industry in Copenhagen. Beautiful venue, amazing audience. We had a really good program. We will run that again next year. We will probably actually have in the spring our own event in Stockholm too. So ENCCS Industry Days event.
But basically to market and to reach out to evangelize on this opportunity.
Yeah, right? Bring together our friends and also new potential contacts, to come together and talk about this rather niche field, HPC. It's not like an AI conference, but there are shared interests and things you can exchange and learn from each other about.
And I can imagine as an entry point for someone who is a little bit curious and maybe even intrigued by this conversation. Ooh, could I use this? So you need to dip your toes sometimes.
But you mentioned next week. So what we have next week is a workshop.
Ooh.
And we'll have it here at the Data Club together with Hyperite and Stockholm AI.
Yeah, which is, and here is Tegnérgatan 16.
Tegnérgatan 16.
14, Tegnérgatan
14. Don't go to the one. And we also do this together with the PDC Center at KTH.
Oh, super cool.
And what's fun about that is that when I worked at PDC, we had two clusters before the current one, which is called Dardel. One was called Beskov. The other one was Tegnér.
Tegnér, of course. Full circle.
Full circle. And so we have an afternoon event where everyone is welcome. It's too late today to get an actual HPC account. If you would have registered a few days ago, you could have gotten the account. But you can still show up and see hands-on demos. How.
So you will have a workshop educating, or is it who is the target audience? Can you be a newbie to HPC, or do you?
Definitely, yeah. I mean, of course, we target people that potentially have a need for compute. So these will not be, these will be data scientists or some such category. So people that already write code in some way and they might run in the cloud, but we want to show them how HPC works, demystify it, show it both in the classical way, log in via terminal, SSH, Linux, module systems, Slurm we already talked about, submitting jobs, but also the modern way using Colony OS.
Oh, so you will actually demo Colony
We will
US.
demo it, yeah.
Maybe we can put the link in the notes.
Yeah,
hopefully, yeah.
Yeah, let's do that. Great idea.
I can't really drop the thoughts about how we can make the Swedish and European sector work better. And if I may be so bold to give you a suggestion into
Absolutely.
ENCCS, Be bold, yeah. This is actually not my idea. It's actually from another European country that did something similar. So
Now you're
this is
adding
not
disclaimers. You were going to be bold.
yeah,
I like you. I like you.
Always careful with my statements. It's a occupational hazard. Anyway, you say you want to help people or companies in Sweden and Europe, or in Sweden in your case, and you have this kind of R&D solution. Why not think Eurovision for cloud compute in Sweden? And what I mean with this is that different providers, companies, startups, SMEs are allowed to compete in a competition where they provide some initial solution, they get some funding from you to do so, and then you evaluate them in different way and you select the winner, and they potentially then get a contract that can help public sector SMEs in Sweden to get access to infrastructure in different ways. Infrastructure not just for R&D purposes, but actually to run the proper product in the end as well. If you were to really push some startups to build this kind of common infrastructure, I think that's something that we sorely need in Sweden and Europe. And if you were to push these kind of initiatives to have at least some Swedish or European competitor to the big cloud providers, I think it would be such an amazing.
Yeah. So we have everything there except for the production deployment environment, right? We have the R&D part, we have monetary support, we have human
But
support.
the competition is for someone to actually be the production environment for a European cloud provider.
Okay.
So imagine they're competing, they're coming up with ideas in order to then we really push and launch a commercial entity
sure.
through a Eurovision context.
It's a private company that provides an infrastructure service that then get a contract potentially for SMEs and public sector in Sweden or whoever is interested in it.
So there's a strong connection between the R&D here with a very targeted goal of creating maybe one of your AI companies like this that is more of an hyperscaler, which is maybe a little bit could be a different ballgame.
And just for your knowledge, there is another company that spent a huge amount of money in this and is been running for 3 years and more, and it seems to work. So I would really encourage you to look more into this and see if we can do something similar in Sweden.
Can we mention the name of the company?
Afterwards, perhaps.
Okay.
But I think it could be amazing because you have to have a sustainable solution. It can't be this kind of ephemeral kind of, we have ENCCS that's supported, yes, but not, long term. If it actually builds up another one that is sustainable and have a business model, it can have such a big impact, I think. Anyway, I'll stop there.
You can dream.
I think it's more than a dream.
Should we go some last more philosophical topics? And I don't know where to connect it. Do you want to have a go?
Yeah. Well, okay, sure. I'm thinking O1 and thinking that we are starting to see AI models now not only having huge amount of knowledge as the large language model does, or the large multimodal models are having, like Gemini, etc., but they also get some reasoning skills now, and perhaps they soon also get some more agentic skills where they can, which already GPT-4o can do. I mean, they can do web searches, they can call out to different APIs, tools like Wolfram Alpha, and so many more things. So they already are starting to become more powerful. And some people, are thinking that it will be a point where we have something called AGI. I'm not sure. Do you have a preferred definition of AGI, Ingrid, if you were to start?
No, I don't. I always ask what the definition is. So
it's going to be a moving target, maybe. I
think your definition is that this is a moving target. That was your conclusion.
It's a moving target, and I think it's probably going to be very incremental.
I think,
hopefully, we're also going to develop our own intelligence and how we complement AI.
Yeah. I think that's the best scenario where we actually have AI that complement humans. But I think Sam Altman's version is rather good. And he basically says that when AI systems become as good as an average coworker, then you have AGI. I think it's rather good.
Yeah. I think, was it OpenAI or somebody else who recently posted like a definition or like a five levels.
The 5 levels. That's a Google paper.
OpenAI has done it as well.
Okay, they have done it as well. I only know the Google one.
Yeah, in OpenAI one, they have the top one is basically organizational one, and then they have PhD level, and they have great these kind of levels.
So this is the down to earth definition maybe of AGI, incrementally start, going from where we are right now, and ultimately we'll have something that's indistinguishable. It has IQ, whatever, and it can do basically everything.
I haven't seen this.
Just make mistakes.
Yeah.
But we're still comparing it to different levels of human type intelligence.
Well, organizational level is potentially not human. It's potentially superhuman because, But it doesn't really matter. We're getting a bit off the topic here, but you can look more into that if you want. But you can define AGI in different ways, and people are going to disagree with it as usual. But you can understand that there, at some point, potentially, they will have an AGI level kind of system, and perhaps even super intelligent, meaning literally better than all humans combined in terms of knowledge and abilities and reasoning skills. What do you think will happen then? If you saw, Nick Boström is a person who has written many books on AI, and he recently released a new book, which is not as skeptical as the previous one. This one was called Deep Utopia, and he basically says, what if we come to an AGI future where everything goes well, and we have utopia? So my question to you basically is, in a very philosophical and speculating kind of fashion, where do you think we will end up in a spectrum? Either this kind of dystopian future where machines will kill all humans, like the Terminator and the Matrix and so forth, or the utopian future that Nick is speaking about, where potentially, and also Elon Musk is speaking a lot about, the world of abundance, the world where the cost of goods and services goes towards zero, and you don't really have to work unless you really want to. You can survive and do whatever you want. But if you want to have some more luxurious kind of things, you probably have to do some work. But it will be a world where you do not have to work, at least. And perhaps a utopian future. Thor, do you want to start? Where in this spectrum?
Well, I think it's fun to think about also more science fiction-like scenarios, because I don't see any reason for why it could not happen that when we reach a certain level of complexity, which is beyond what is currently done, somehow interconnected neural networks, specialized neural networks on different things that are interconnected, they have certain agency. We're talking about agentic and so on. Why could it not happen that there is a runaway process in the Kurzweilian sense, with a singularity, like there's an intelligence explosion? And that's fascinating to think about and also very scary. And what that would lead to, it's completely unknown, I think, because a super hyper, extremely intelligent agent, which is omnipotent as well, has all the resources, has robotic embodiment and so on. I mean, we have no way of knowing what that would lead to. It could be utopia, it could be dystopia. It could, for some reason, come up with a goal that colonizing the galaxy is the best way to proceed, and then humans become completely irrelevant in that context. Or it could be like the unheard of flourishing of humans. So that I don't know which way to lean there.
Are you above or below 50% utopian, dystopian?
Let's say 50-50, exactly.
Okay.
But that's more science fiction like way to look at it. I mean, the other way is just incrementally. I mean, maybe we will have AGI in a couple of years when we just eliminate the bugs, we eliminate the hallucinations, and gradually it becomes, an AGI, and model that can be the CEO of a company. It can be a scientist, and to me, the utopian future there is that everything, science will progress as never before, because everyone can be a citizen scientist. You have the perfect scientist assistant, and everything will be open source, shared between humans and so on.
Everyone can be a programmer perhaps as well.
Everyone can be a programmer. There will be no need to be a programmer. I mean, the AI will do the programming. But just given the current state of the world, it's a little bit difficult to see that this is the most likely outcome, when all the power and the resources are in the hands of a few companies, and there's geopolitical terrible situations in the world. There's war, there are aggressions, and humans are not behaving in a very ideal way. Yeah. So I'm also rather ambivalent on which scenario is more likely in that more sort of down to earth way to speculate about the future.
I like the way you were painting the pictures here. And of course, impossible to answer, and even but also for you, I mean, like it's even sometimes like, damn it, on a Monday I feel more 40%, and on a Friday I feel more 60%.
It depends on whom I'm talking to. Like I have friends who are very doomsday, ish, doomsday prediction guys, and
but then you go the opposite. Used to.
Yeah, that I tend to sort of push against whoever I'm talking to. So
I like that.
Love it. I do the same. I think it's fun, but annoying to the other person. Cool. Ingrid, what's your thinking? Will we end up in a dystopia or utopia?
Yeah, I mean, you're right in the sense that, but if everyone can become a citizen scientist, everyone can also become a quite efficient terrorist.
Exactly.
So, I mean, there are pros and cons of everything, and AI is a tool that can be used for good and bad. I mean, I don't see sort of physical law that says, given, endless time and compute and experimentation, that we would not be able to end up with some kind of super intelligence. But I don't know whether what we're doing now is incrementally going towards that direction, because everything we're doing now is kind of trained on data, either language data or sensory data. And it's a little bit going back. I'm reading this book about sort of the origins of quantum physics, actually, called What is Real. And then there's this discourse in the beginning of the 1900s about, like, is science what we can see, or the theories about what we can see? But regardless of which, like, we are training the models on stuff we feed it, but we don't feed everything. So what I say will never 100% represent what I think, but we are humans. So we kind of function a little bit similarly. So we can infer that difference between what I can express and what I actually mean. But computers don't really work that well, so they become quite literal. So I'm not entirely sure that these sort of LLMs or sensor-based models will at some point.
What's lacking?
I don't know. I mean, but so I don't claim to have the answer. I'm just not sure we're going in that direction. But I think at some point, there's no reason where we wouldn't end up with a super intelligence or AGI. And then going to your question about, do I think it's going to be a great future or a horrible one, or perhaps no future at all? So I have a friend who uses a great term called purposeful delusion. Okay. Basically meaning that whatever I think about this is not going to impact the outcome a lot, but I'm going to feel a lot better thinking it's going to be a utopia. And then I might also think about what kind of utopia might I want to work towards. So I tend to lean positively. But on the other hand, like when you're talking business, for example, it's normally much easier to sell pain than to sell gain. So you might have to also think a little bit about the utopia for people to actually like feel a sense of urgency to make sure that we don't end up there. But I tend to be an optimist.
Nice.
Awesome. Cool.
Love
the
it.
time has flown away, and super interesting to have you both here, Ingrid and Thor. I hope you can stay on for further off-the-camera kind of discussion. Speaking about quantum physics is one I would love to speak more about.
We didn't even talk about quantum computing. Okay.
No, but it's one of my favorite topics, actually. But,
Awesome.
No, we have to do it off camera.
Turn off the camera and bring
Yes, from
tequila.
HPC
Let's
to
go.
quantum computing. That's
So if anyone is interested in quantum computing, talk to us as well. We do quantum computing also.
Yes.
Ooh.
Yeah.
No.
I think you should be glad you did speak to me. Anyway, awesome. Thank you so much for coming to this podcast, Ingrid and Thor.
Thank you very much. Honored.
Thank you so much.
It's been great.